We basically live our lives online, right? But underneath every single click, every stream, every file we share, there's this huge physical superhighway. It's made of glass and light, and it's run by some seriously high-stakes economics. In this explainer, we're going to pull back the curtain on this hidden world.
I mean, we take it for granted, don't we? You hit send on some huge file and seconds later, it just pops up on a screen halfway across the globe. But what actually happens in those few seconds? What kind of insane journey does your data really take?
So, to figure this out, we're going to follow our hero. A single, tiny packet of data, think of it as our digital protagonist. We're going to follow it on its epic voyage, from your screen, out into the wild, and right through the very core of the internet. Okay, so our packet's big adventure kicks off the second you say, drag and drop a file to send to a colleague overseas. That one simple action, it instantly shatters your file into thousands of these little packets, and now, every single one of them is on a mission. The very first challenge for our little packet is just to get out of its own neighborhood. To do that, it has to climb this kind of ladder, a ladder of internet service providers, or ISPs, just to reach that global superhighway. So our packet starts at the bottom rung with a Tier 3 ISP. That's your local provider. Now, they don't own a global network, so they have to pay a bigger regional Tier 2 network to carry their traffic. But even the Tier 2 guys don't cover the whole planet. For that, our packet has to get to the very top, a Tier 1 provider. And yeah, this climb is not free. It's a business, and the service is called IP transit. The best way to think about it is like buying a series of toll passes to get onto bigger and faster highways. Each tier pays the tier above it for access to the rest of the world, and our packet's ticket has just been punched. And just like that, our packet has reached the big leagues, the absolute pinnacle of the internet hierarchy, the Tier 1 backbone. This is a super exclusive club of giant global networks that are all more or less on the same level. We're talking about the titans of the internet here, companies you've definitely heard of, like Lumen, AT&T, and Verizon. These guys operate these massive worldwide fiber optic networks, and together, they basically form the internet's core. And because they're all at the top, they get to play by a different set of rules. They don't have to pay for access like everybody else. So while all the smaller networks are using that IP transit, the toll booth model, Tier 1 providers connect using something totally different called internet peering. It's basically a handshake agreement. They say to each other, hey, I'll carry your traffic for free if you carry mine, because, well, they both get huge benefits from having direct access to each other's massive networks. And the benefits of this peering handshake are just huge. By connecting directly, our packet gets a much faster, more direct route. In tech speak, that's lower latency. It's way cheaper because no one's paying those crazy transit fees, and it's even more secure. This whole handshake model is what makes the global internet feel so fast and efficient for all of us. So where do these all-important handshakes happen? Well, they happen in these incredible real-world places called Internet Exchange Points, or IXPs. You can literally think of them as the world's busiest international airports, but instead of people, they're for data. They are these massive buildings where hundreds of networks physically plug their routers into shared equipment to exchange traffic directly. And the scale here is it's mind-boggling. At Desix in Frankfurt, which is one of the biggest IXPs on the planet, peak traffic has topped 15 terabits per second. That is enough data to stream several million HD movies all at the same time. Our little packet isn't just traveling anymore, it's riding a data tidal wave. Okay, so we've talked about all these networks and business agreements, but what is our packet physically traveling through? I think the answer is actually going to surprise you. Do you remember years ago when the internet was famously and kind of clumsily described as a series of tubes? Well, it turns out that researchers who were studying the actual physical layout of the internet, they concluded that this metaphor, well, it's actually pretty spot on. Because, and this is the crazy part, the long-haul internet is, quite literally, a network of fiber optic cables running through conduits, or tubes, buried underground. And what's really wild is that these fierce competitors, companies like AT&T and Verizon, often lay their fiber right next to each other in the exact same trench. So why on earth would they do this? It's simple economics, really. It is astronomically expensive to dig new trenches across the country. But this creates a massive hidden vulnerability. A single construction crew with a backhoe in the wrong place can accidentally sever the connections of multiple competing Tier 1 networks all at once, leading to these huge, widespread outages. It's a shared risk right at the physical heart of the internet.
So our packet is getting close to its destination, but its journey really highlights this constant pressure that's on the physical network, this absolutely insatiable demand for more and more speed.
Right now, 400 gigabits per second is becoming the mainstream speed for these huge backbone networks. And that is incredibly fast. But believe it or not, the demands of new tech are already pushing the limits of what even that can do.
The next big leap is already on the way, 800G, and it's expected to ramp up fast, starting around 2026. The main reason for this insane jump? You guessed it, artificial intelligence. AI requires moving these colossal data sets between data centers just for training models.
And you think that's fast? Beyond that, service providers are already starting to adopt 1.6 terabit per second solutions. That is 1,600 gigabits per second, all flowing down a single strand of light. And it's all just to keep up with the biggest AI workloads.
And here's why this is all happening so fast. By 2030, which is just a few years away, it is predicted that AI will be responsible for 2/3 of all traffic on the internet. That's the tidal wave that this physical superhighway is frantically being upgraded to handle.
So, our little data packet finally completed its incredible journey, racing through this complex web of business deals and literal physical tubes. Its journey really highlights a fundamental truth. Our seamless, amazing digital world is built on top of a very real and surprisingly fragile physical foundation. And that leaves us with a pretty critical question to think about. Is this invisible superhighway really as resilient as we've all come to believe?